To solve this problem, I need to find the critical points. I need to find where the function is increasing and or decreasing. And I need to find the extrema and say if they're a maximum or a minimum. And I can't forget to write them in an order here. So the first thing that I need to do is take the derivative, because the derivative is going to help me find all of these things. But before I can take the derivative of this function, whenever x is in a denominator or under a root, a cube root, a square root, whatever it is, we cannot take the derivative until we rewrite the problem. So I'm going to rewrite this as x plus 4x to the negative first power. Now that I have rewritten it, I can now take the derivative. So h prime of x, the derivative of x is 1. Then I use the power rule here instead of the quotient rule. You could do the quotient rule with 4 over x, but it would be long and unnecessary. So you might as well use your exponent rules to rewrite it. Use the power rule to get a negative 4x to the negative 2. So this is my derivative. But just like I had to rewrite the problem to take the derivative, I do need to rewrite this problem to be able to find my critical numbers, because there's an important part of this problem that you would miss easily if you didn't rewrite it. So to rewrite it, I have 1 minus 4 over x squared. Now remember, my critical numbers happen when my derivative is equal to 0 or undefined. This is something you need to check before you set this equal to 0. There is a place where this derivative is undefined. It's anywhere a denominator equals 0. Here the denominator is x squared, so wherever x equals 0, it is undefined. So this is already one of my critical numbers that I have. Without even setting it equal to 0, I have 1. So that will be a number on my number line. Now I have to find any others. So I'm going to set this equal to 0, 4 over x squared. And I'm going to add the 4 over x squared to the other side, because I need to split up the 1 and 4 over x squared. If I move the 4 over x squared, it'll be positive. So I'm going to do 4 over x squared equals 1. Now my goal is to solve for the x squared down here. When something is in a denominator, I cannot solve for it. So to get it out of the denominator, I'm going to multiply each side by x squared. So here it'll cancel. Oops. The computer doesn't always like this. Let's fix that. Okay. Here they cancel. And we have 4 equals 1 times x squared is x squared. Now I'll take the square root and I will get 2 answers. Do not forget the negative. We'll get a positive 2, but we will also get a negative 2. So now I have 3 critical numbers. I have x equals 0, x equals 2, and x equals negative 2. These 3 numbers I am putting on my number line to do the first derivative test. The first derivative test will tell me, derivative, I-V-E, let's spell that right, will tell me whether a maximum or minimum is happening at my critical numbers. So I'm going to put these in order. I have negative 2, I have 0, and I have positive 2. And for my first derivative test, I need to choose some test numbers in every interval in between and on the outside of critical numbers. Now, it's important that you distinguish between your test numbers that you're just choosing to plug into the first derivative and your critical numbers. So what I do is I leave my critical numbers on the bottom, and on the top, I write my test numbers. So negative 3 on this side and negative 2. Negative 1 here, positive 1 here, and positive 3 here. You can choose anything you want. Those are just the ones that I decided to use. So I put them on top of the number line and circled them. So I know that I'm plugging these into the derivative because these are for my first derivative test. Okay? The numbers on the bottom I will eventually plug into the original if I have a maximum or minimum there. So let's plug in these numbers. When you plug in -3 to your derivative, so let's look back up at our derivative. Our derivative is 1 minus 4 over x squared. When we plug in -3, we'd get 1 minus a fraction. We'll have positive. When we plug in -1, we will get a negative. When we plug in +1, we will get a negative again. When you plug in +3, you will get a positive here. So you can use your calculator to figure that out. Okay, I'm just plugging those into the derivative. Now I need to look at where it is increasing and decreasing. A positive derivative means that my original function is increasing. There it goes again. Let's undo that. Okay. So a positive derivative means that my original function is increasing. A negative derivative means my original function is decreasing. So it is decreasing here and here. Again, my derivative turns to positive at the end, so it is increasing. So we can go ahead and write our intervals for increasing and decreasing. Increasing is happening wherever my derivative is positive. So from -infinity to -2, it'll take a break there. 2 is included. My derivative is 0. That is defined. Okay. And then we pick back up at 2 and go to infinity with increasing. Now let's look at decreasing. We have two sections that are decreasing, and they are connected. But something does happen at 0. My derivative does not exist. That means something in my original function is happening. If I look at my original function, I have an x in the bottom. My original function is not defined there either. So I don't have any graph there. So I cannot say that it is decreasing or increasing. So I have to skip over 0. So for my decreasing intervals, or interval in this case, it's from -2. It goes to 0, but remember we hop over 0. So our notation for hopping over, we need to not include 0. So we have everything on that side of 0. And then we need to hop over 0, pick back up right after 0, and go all the way up to 2. So that is where my decreasing intervals are. Even though they look connected, we need to hop over that 0 because it is not in our original function's domain. Okay? Now we can look at these numbers. I will have a maximum here because I go from increasing to decreasing. Nothing happens here because the sign does not change. And when I go from decreasing to increasing, I will have a minimum. We already know our x values for these two. We know that our maximum will have an x value of -2, and we know our minimum will have an x value of +2. When you plug in -2 to the original, going all the way back up, -2 plus 4 divided by -2. That's -2 minus 2 is -4. Now if that 2 were positive, we would have a +2 plus 4 over +2. 2 plus 2 is a +4. And there are minimums and maximums. So we have answered all parts of this question. Maximum, minimum, decreasing, increasing, and our critical numbers were back up here. 0, +2, and -2.